Warning: sulfuric as well as hydrochloric acids are both corrosive. Hydrogen chloride is toxic to the respiratory system. Take caution and work in a well-ventilated area if you want to replicate this experiment. Hello everyone! Today I'm going to show you how I made fuming hydrochloric acid. This acid is a solution of hydrogen chloride gas in water, and it is classified as a strong acid, as its pKa is about -6. To begin, I added 146 grams of regular table salt into a 1 liter 3-necked round bottom flask. I installed the flask onto a clamp and began constructing the reaction apparatus. I put in one of the biggest magnetic stir bars I could find and attached an addition funnel to the middle neck of the flask. Next, I attached a heating mantle and put the flask inside it. Now, although the heat from the reaction is enough to keep it going, heating it even more can cause it to release more HCl gas, which will ensure I get a saturated solution. I stoppered the left neck of the flask, and to the right one, I attached a small tube which will get the gas out of the flask and into the rest of the apparatus. It's important to use clamps or grease the joints, because you don't want any air to get into the system. I then connected a middle vessel, which will act as a safety measure if the acid gets sucked back or the contents of the reaction flask boil over too much. I fortunately didn't use it, but I recommend keeping it just in case. Now, while I attach all the tubing, I can tell you about the course of the reaction. What will be happening here is called a double displacement reaction, which means that two atoms in different compounds switch places with each other, creating two new compounds. Here, the sodium atom from sodium chloride will go into the place of one of the hydrogen atoms in sulfuric acid, and the hydrogen atom will bond to the chlorine, creating hydrogen chloride and sodium bisulfate. Going back to the reaction vessel, I added a compartment in which there will be water for the HCl gas to dissolve in. The piece most to the right is a bubbler, and it will indicate if there's still air in the system, as well as if the acid solution is saturated. Once the whole apparatus was ready, I poured 110 milliliters of water into the before-mentioned tube and drew a line at the surface of the water, because the more HCl gas is dissolved in water, the larger its volume is. Dissolving the hydrogen chloride is also exothermic, which means that it releases a lot of heat, and the colder the water is, the more gas can be dissolved in it. So I threw in some regular ice into a beaker under the water-filled tube to create an ice bath. Next, in a graduated cylinder, I measured out about 215 milliliters of 98% concentrated sulfuric acid and poured it into the addition funnel over the flask. You have to be really careful during this step because sulfuric acid is very corrosive. Once I was ready to begin the reaction, I opened the valve of the addition funnel so that the acid would be added dropwise. You can immediately see white fumes, which are small droplets of hydrochloric acid forming when the HCl gas reacts with tiny water droplets in the air. On the inside of the flask, you can see the reaction happening and how it is producing a lot of bubbles and foam. This foam, as nice as it looks, is actually just the corrosive hydrogen chloride in sulfuric acid escaping into the latter part of the system. Now, because there was a lot of air in the whole apparatus, you can see how it's being pushed out by the HCl gas, and none of it is dissolving in the water, which you can more clearly see by the bubbles in the bubbler. If there was no air, the produced gas would be dissolving in water, and there would be little to none action happening in the bubbler. Here you can see the mixture in the flask rising and expanding. With the stirring turned off, you can see really beautiful waves that are created by the difference in densities of water and hydrochloric acid. When the stirring is turned on, the solution becomes more even. Now that there is not much air inside, you can observe that the bubbler is much more calm and there aren't so many bubbles inside it. When about half of the sulfuric acid was added, the volume of the boiling flask's content had increased quite a lot. At the point when there was very little air, the HCl was dissolving so quick that you almost couldn't see the bubbles escaping. The bubbler had also almost completely stopped producing bubbles. After adding all the sulfuric acid, the reaction had become less violent and I decided to leave it that way for about 5 minutes before going on to heating to speed it up again. I didn't record the exact moment when I started heating, but here you can see just how much had the reaction grown just because of heating. This also increased the rate at which the gas was produced, and you could see that in the water vessel. Another cool thing here is that you can see the increased volume of water because of the dissolved gas. As time passed, the volume of water just kept increasing. When the solution became quite saturated with hydrogen chloride, I put a wet piece of litmus paper to the end of the bubbler, which made hydrochloric acid and dyed the paper red. This was also the point when I decided to finish the reaction, and I first removed the ice bath, then changed out the top of the acid-containing vessel to a stopper and pulled it out of the clamp. I poured the hydrochloric acid into a graduated cylinder, but even this was harder than I thought, because the acid released hydrogen chloride fumes I couldn't be near and had to hold my breath because the smell was really awful. In the end, I measured I had about 150 milliliters of the acid and weighed about 183 grams, which meant that its density was about 1.22, which corresponded to a concentration of about 40%. That would be all for this video. Thank you for watching, please subscribe and see you soon.